All right, let's begin. What are piecewise functions? All right, we have a lot of piecewise functions. These are called piecewise because they are in pieces. So take a look at this function over here. This one over here, this is a piecewise function. How do I know? Because we have one piece of a function behaving in one way, and then another piece of the same function behaving in another way. This is why we have piecewise functions. Now, how can we detect a piecewise function? We can detect it by looking at the drawing, just like I said, right? Just from the behavior, or we can detect it from these types of expressions. Look, in the past, we have worked with f of x equals and then just one line of instruction, right? But in this case, we have this corchete. I don't know how to say that in English. Bracket? Whatever. We have this thing over here. In this case, we have this thing over here, right? And we have two instructions. Now, each of these instructions is going to give us different lines, right? All right, the best way for me to help you to understand this a little bit easier is to do one exercise. So let's begin with the first one. We're going to do this one. For each of the following piecewise functions, we have piecewise linear, or this could be piecewise quadratic functions, or piecewise exponential functions, whatever. Just piecewise functions. We're going to state the domain, plot the graph, and find f of 3 and f of negative 3. Right? Now, what are those piecewise functions? The first one is this one. So let's graph this one, and from the graph, we can state the domain. All right? To do that, let me change into my board. All right, give me a second. I'm going to copy the function, and then I'll show you in the board. F of x equals, and then we have in pieces 1 plus x and 9 minus x, 9 minus x, right? Negative 3 lower than equal than x, lower or equal than 4, and here we have 4 lower than x, lower or equal to 10. All right, beautiful. Okay, let me change to my board now. Beautiful. All right, hello guys. All right, so we have in the board the function that we wanna plot. How do we plot this function? How do we plot these functions? To be honest, it is pretty easy. The first time we see something like this, we might be scared a little bit because we are not familiar with this, right? It is okay to feel that way, but it isn't hard at all. It isn't hard at all. What you do have to do is recognize that since this is a function by pieces, piecewise, we are going to have two pieces of a drawing. It's that simple. All right. Here is how you would plot this. Let's begin by doing the Cartesian plane, right? Now, I don't have ruler, so my drawing is going to look awful. All right, so we know from the value of x, we are going to accept values from negative 3 to 4 for this function, for this piece of the function, and from 4 to 10 from this other piece of the function. So I'm going to draw it from negative 3 over here, negative 3 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. It's going to be the x and it's going to be the y. Beautiful. How do we plot now? Simply by doing a bunch of points and then linking those points through lines. All right. Let's begin with the easiest ones. I am going to select points from the value x. I'm going to select points from the value of x from negative 3 to 4. All right. So here, let me do a little tabulations for you. Tabulation. All right. So we have x and we have y. Like this. In here, again, select values from negative 3 to 4. Why? Because this one this little piece of domain is telling us that the values that are from -3 to 4 are the ones that are going to be for this piece of the function. So if I select this one, -3, let's select another one, -1, another one, 0 and 2, and then 4. I don't have to select a lot of values. To be honest, I could have just select 2. If I wanted, I could have just selected 2. Why? Because we know from the equation, we know that this is a line. So all we know is just 2 points. With those 2 points, we take the ruler and create the line. I'm just going to show you how to do this with a lot of examples. But again, if you just want to show 2 points, that is okay. From here, let's try to find the values of y. Remember, y is also the f of x, right? Let me write it that way, maybe. F of x. So all we do now is change the value of -3 in the piece of the function. So we have 1 plus -3. Okay, that'll be 1 plus -3, which is 1 minus 3, so -2. Beautiful. We have our first point, -3, -2. That'll be our first point. All right. If we want to plot that point, we come over here. I'm going to do it with green. This point will be -3 in x, -2 in y. So around here, right? Beautiful. We have our first point. We continue doing so until we have a clear idea on how the graph is going to look. That's simple. Now the question is, teacher, why didn't you replace the -3 here? Look, here is an x. Why did you replace it here and not here? Because of the domain. Here we have an instruction. Each piece of the function has an instruction, has a domain related to that piece of the function. So for this piece, only the values between -3 and 4 inclusive are going to go here. And for this piece, only the values between 4 and 10 inclusive are going to go here, right? If I have a different value, I am not going to count it. So for example, if I selected -10, the -10 doesn't belong to this or to this. The -10, this is an example again, does not belong to any of the instructions, any of the domains. So I'm not going to replace it anywhere. My domain in the function cannot have the -10. It cannot have the -10. All right? So from here, we know that the domain of the function will be from -3 all the way to 10. Lower than -3 cannot exist. Bigger than 10 cannot exist. All right. Let's continue with the drawing here. I'm going to do all these replacements as fast as I can. So 1 plus x, 1 plus -1, this is 0. 1 plus 0, this is 1, right? 1 plus 2 is 3, and 1 plus 4 is 5, right? Now that we have our points, all we have to do is plot them. Just come over here and plot all of these. So you have the first one, -1 and 0 is going to be around here. 0 and 1 over there. 2 and 3. 1, 2, 3. And then 4 and 5. There we go. Look at that. The dots kind of create a line, right? Which is why from the beginning I said we don't really need these mass points, these many numbers. We don't need them. We don't need them. Because if we know the function is going to create a line, all we need is just 2 points, right? All we need is 2 points. Beautiful. We have done the first part. With the first part, we know our line behaves this way. There we go. We have our line. We did the first one. Hey, beautiful. What happens with the second one? We just do the exact same process with a bunch of different numbers. So let me erase all of these numbers and create new ones. All right. Now, I want to I always want to know what happens in the corners of the numbers. So how does the function behave? In other words, what is the point related to 4 and related to 10? What is the point related to -3 and related to 4? I always want that. So those have to be 1s of our options. The first one is going to say it's going to be 4, and the second one is going to be 10. Now, if I want more points, I simply select more points. Let's pick one in the middle, 7. All right, we have 3 points now. And from here, we just find the value of y. In the first one, this was 9 minus x. Notice how, since the values 4, 10, and 7 are from this one, well, this is the function that we are going to replace it then. So 9 minus 4 is going to be 5. 9 minus 10 is -1. And 9 minus 7 is 2. Beautiful. Now that we have our points, we can create a line. Again, I could, if I want to, create more points simply by selecting more numbers in the x. Of course, those numbers have to be between this range, from 4 to 10. From 4 to 10. But because I know this is a line, I don't need that many points, right? All right. I'll come back to this point, and all I have to do now is plot this one. So 4, 1, 2, 3, and 4 with 5. 1, 2, 3, 4, 5. Look at that. The same point. Another one, 10. So 4, 5, 6, 7, 8, 9, 10 with -1. There's another point. From here, I can make the line, and that is it. But I had a third one. 7, 2. So 4, 5, 6, 7, and 2. Beautiful. So now I know my line is just like this. And we stop right there. Notice a couple of things. Number one, we are stopping right in the corners of the values. -3 was one of the corners. That is one of the value here, -3. 10 is another corner. So we stop right there at 10. We do not continue the drawing. We don't continue it all the way. We don't make an arrow showing that this continues to infinity. We don't do that. Because in this case, the only piece of domain, the only intervals are from -3 to 4 and from 4 to 10. Those are the only pieces of information. If we do something more than this, then the drawing will be wrong. All right. So now we have our drawing. Again, domain, we said it at the beginning, right? Domain are all the possible values that x can take. And from here, the same function, the function itself, is telling us what are the values that x can take. So we can take from -3 to 10. That's it. From -3, look, from -3 to 10. That is the domain. Now, the plotting is right there. That is how you plot these functions. Let's continue with the third question, because I don't remember the question. This one. Find f of 3 and f of -3. F of 3 and f of -3. Erase this part. We want to find f of 3 and f of -3, right? That is how you read it, by the way. F of function of 3, function of -3. But what do you mean by that? Simple, pretty simple, to be honest. All we have to do is replace the value of x in the appropriate function. Now, for this case, since the value of 3 belongs to this range, then we are going to replace it in this piece of the function. And in the one down, -3 belongs to, again, the same range. -3 belongs to this one over here. So we are also going to replace it in the first piece of the function. That's it. So let's do that process. In here, I have 1 plus 3. So f of 3 is 4. That's it. That is it. We just did the first part. F of 3 equals 4. That's it. What about -3? Again, 1 plus -3. If we do this process, this will be 1 minus 3, right? 1 minus 3, which is exactly -2. So now we have the two answers, and that is it. That is it. There's nothing else to it. All right. I feel like that is absolutely easy. All right. How about this question, guys? How about this exercise? Do you have any questions about this? If you don't, please in the chat say, no, we are okay. All right, thank you guys. Thank you to all the people who are actually writing something. It means a lot to me because I cannot see your faces, right? So I don't know if you guys are understanding or you're having difficulties or what part of this should I explain again or differently, right? So thank you to the 11 people who actually said something to me. Thank you guys. Appreciate it a lot. Appreciate it. Thank you. All right. I feel like this, of course, I'm not going to do the B. I'm not going to do the B one because it is exactly the same, right? No, it's not the same. We have something new here. All right, let me do the B first, and then we continue with some more examples. Let me copy this in the board. Yes, I have to do this one. There is a little change in the question B. There is just a little change in the question B. Just a little change. All right, f of x equals B's function x if x is bigger or equal than 0 and negative x if x is lower than 0. All right, beautiful. We can also find f of 3 and f of negative 3. All right, f of 3. Beautiful. All right. All right, the part B of the question, guys. The part B. So let's begin by doing this little by little. The first question was state the domain. All right. Now the domain we can always state it from the conditions here, from the instructions, the domain of each part of the main function. In this one, we have that if the value of x happens to be bigger or equal than 0, we do some things. Bigger or equal than 0. That means the domain includes every single number that is bigger or equal than 0. Every single number that is bigger or equal than 0. So every single positive number, all of the possible numbers. Look, in the previous exercise, we had a range. We had from one number to another one. But in this case, we don't have from one number. In this case, we are accepting every single number that is bigger than 0, bigger or equal than 0. So we have every single possible number. That is the domain so far. What about the second part? All right, the second part says that if the number is lower than 0, so now we're talking about every single negative number, right? So if the number is positive, we accept it because of this part. If the number is negative, we accept it because of this part. Meaning the domain is every single number that we have. All the real numbers. Let me write it here. Domain. Domain will be all of the real numbers. Every single number. Because we can accept from every negative number all the way to every positive number. That's it. We don't have a restriction. Now that we have this, we can draw the drawing. We can draw the drawing. All right. Something like this. All right. Beautiful. All right. That'll be my Cartesian plane. All right. Instead of plotting the points here, I'm going to show you a different way of doing this. Simply because we know that these are lines, simply because we know these are lines, we can plot these lines a lot easier in the plane just by using what we know as the slope and the y-intercept. All right. From here, in the first line, we know that the slope is 1. This is 1x, right? So the slope is 1, and then this is plus 0. Meaning we have a slope of 1 and a y-intercept of 0. So our line will begin from 0, that is the y-intercept from 0, and then it's going to move one left and one right. One left, one right and one up. One right and one up. One right and one up. That is the slope. So this will be our line. Right? Now, notice how I did it just from 0. I didn't also extend it downwards. Why? Because of the instruction, the domain. I am only going to draw x, this part, if the value of x is bigger or equal than 0. So only for the positive, only for all of these values which are positive, only for all of those. These are the values of x that are positive. So from 0 and up. Now, in this case, I can now put a little arrow. In this case, now I can put an arrow because I don't have a restriction to where to stop. In this case, it goes to infinity. I am accepting every single number. So I can draw an arrow showing that this continues to infinity. Beautiful. But what about the second part? All right. We can draw the second part exactly the same. The slope is now -1. And the y-intercept is still 0. But the drawing is only going to be for the negative values. So for these ones, these are the negative values. So I'm going to begin with 0 again because the intercept is 0. The y-intercept is 0. And then I'm going to move downwards. 1 to the left, 1 down. 1 to the left, 1 down. Because then slope is -1. 1 to the left, 1 up. Sorry. It's like this. And then the little arrow to show that this continues to infinity, right? This slope, this line has a negative slope of 1. This line has a positive slope of 1. This is the drawing of our function in here, all right? Of course, if you don't like this way of drawing the functions by using the slope, by using the slope and the y-intercept, if you don't like that, that is okay. You can always just do the tabulation that we did in here, right? Creating the little table and writing some values for x and finding the value for y. You can do that if that is what you want to. I just find this to be a lot easier, especially when we have practiced this. All right, now for the last part. Let's find f of 3 and f of -3. To find f of 3, in the chat, please. Do I replace x in the first function or in the second one? For first or second? In the chat, please. All right, I'll do it then. For f of 3, right? Again, remember, we are trying to find the value of x, the value of y, sorry, the value of the function when x equals 3. So all I have to do is replace x on the appropriate domain. Now, we are looking for 3. This is the value, 3, right? So what of these two domains includes the 3? Does the first one includes a 3? Man, stop camera. Man, all right. Does the first option includes a 3? Or does the second option includes the 3? Which of the first one? Which of the two? The first one or the second one? Which of the two includes the 3? That is the question right there. All right, people are saying the first one, the first one, the first one, the first one. Beautiful, beautiful. X. That is it, guys. If you want to find the value when x equals 3, x equals whatever, simply go back to the piece of instruction and think about which of those includes the value that you are looking for. Since we are looking for 3, and we know the first one is the values that are bigger or equal than 0, then 3 has to belong to the first part. These one are the values that are lower than 0. 3 is not lower than 0. 3 is bigger than 0. So we replace it in the first one. That's it. How do we replace? Simply by changing the value of x for a 3 and then doing the operation. That's it. We're going to change the value of x by a 3 and then do the operations. If we change the value of x by a 3, we're going to have that this is 1 times 3 plus 0. Let me write it here. 1 times 3 plus 0. 1 times 3 plus 0. If we do this operation, we're going to have this is exactly 3. That is it. We did it. The main difficulty here, the main difficulty is knowing where to replace the value of x. Do we replace it in the first one or in the second one? That is the main difficulty. Let's go with the second one, negative 3. I have to replace it in the second option, simply because this is a negative value, negative 3, right? And this one says that we are going to include the values that are lower than 0, so negatives, right? If I do that replacement, I'm going to have negative 1 times x plus 0. So negative 1 times 3, times negative 3 plus 0. I just did the replacement. Instead of negative 3, instead of x, I'm going to write negative 3. That is what I did. Look, negative 1 times x times negative 3 plus 0, plus 0. From here, do the mathematics, do the calculation. So we have negative and negative. That will be positive. 1 times 3, 3, plus 0, 3. So when x equals 3, y will be 3 as well. When x equals negative 3, y will be negative 3 as well. And we can see that here in the graph. Look, if x is 3, right here, x equals 3. So we are saying this number. What is the value of y? Also 3. Did you see? When x equals 3, y equals 3 as well. But also with the negative 3. This will be the value of negative 3. This is 1, 2, 3. Here, this is negative 3. If I go up on the line, same value. When x equals negative 3, y equals, this is x, and this is y. Y equals 3. All right, I feel like now it is enough. The only thing that I wanted to show you differently is the use of these little arrows. Arrows, we use them when we want to show that the function continues to infinity. In the first exercise, in the first drawing, we didn't use arrows because the function had a domain restricted, right? We stopped at one point. In this case, we don't. So we have to continue, right? Beautiful. All right, let's continue with some other examples. Let's stop the recording here and begin a new one for the other exercise.